A yearbook company promises to give the junior class a picnic if they spend at least $72,000 on yearbooks and class rings. Each yearbook costs $75 and each class ring costs $375. How many yearbooks and or class rings must the junior class buy to get their picnic? So, this is a problem that can have a whole lot of different answers. If they bought 0 class rings, they could still reach their goal by buying nothing but yearbooks, right? If they just bought a whole bunch of yearbooks, they could get to at least $72,000. And likewise, they could buy 0 yearbooks, buy nothing but class rings, and still get to $72,000. But probably what they're going to do is they're going to buy some combination of the two, some yearbooks and some class rings. Might be a bunch of yearbooks and a few class rings, or vice versa. Might be pretty close to the same amount of both. The point is, there's a lot of answers, which makes this problem perfect for an inequality, because when we solve a problem using an inequality, we've got that shaded section of the inequality that includes lots and lots of answers, all of the points inside that shaded section. So let's go ahead and set up the inequality first. And the first thing we need to do is define our variables. So the two things that we have, of course, are yearbooks and class rings. So let's say y is the number of yearbooks that they buy, and we'll say r is the number of class rings. Or you know what, since we're going to graph this, let's just make x the number of class rings. So y is the number of yearbooks, x is the number of class rings. We'll use y and x so we can graph it. Okay, so we need to go ahead and set up our inequality. So each yearbook is $75. So the amount of money they get from yearbooks is going to be $75 times however many yearbooks they buy. So same thing for the class rings. Class rings are $375, so it's going to be $375 times however many class rings they buy. And the total of these two things, meaning if we add these together, needs to be at least $72,000. So at least means 72,000 or more. If they get 72,000, that's fine. But if they sell more than 72,000, it's not like the company's going to say, "Oh, I'm sorry, we said 72,000 and you bought 100,000, so you lose." No, they're going to be fine with more than 72,000. Okay, so if we're going to graph this to see what the solutions are, we need to solve this for y. So our first step is going to be to subtract 375x on both sides. And so that's going to give us 75y is greater than or equal to negative 375x plus 72,000. And then we need to divide everything by 75 to get the y by itself. Divide everything by 75. Okay, so I know 75y divided by 75 is y, and I know I don't have to flip the inequality symbol because I'm dividing by a positive, but I'm going to need a calculator for everything else. So let me go ahead and grab my calculator, and I'll do 375 divided by 75, and that gives me 5. And then I'll do 72,000 divided by 75, and that gives me 960. Okay, so if I was going to graph this, I would have a y-intercept of 960, and the slope would be -5, which would be -5/1 when written with rise over run. So if I just did a real rough sketch of this, let's just do a real rough sketch. We said x was going to be the number of rings, and we said y was going to be the number of yearbooks. And we know that we're going to have a y-intercept of 960. and then it's going to go down by 5 for every x. So we could real quick figure out 960 means if I buy only yearbooks, if I buy nothing but yearbooks, 960 yearbooks will get me where I want to be. That's the y-intercept. The x-intercept is going to tell me if I buy 0 yearbooks, how many rings would it take? And we can figure that out too. Probably will need a calculator, but that's okay. Let's substitute the y for 0. And I'm going to do this as an equation because I want to know exactly how many rings it would cost to land on exactly $72,000. Meaning if I want to hit exactly $72,000, and I want to do it by only buying rings, 0 yearbooks, only class rings. How many class rings would it take? This is what the x-intercept is going to tell me. The x-intercept tells me class rings only. So negative 960 divided by 5 is going to be, let's see, that'll be 192. I think 192, but as long as I've got a calculator, why not check? I think it's 192. It's not 192. I'm going to be so embarrassed. So 960 divided by 5. Oh, thank goodness, 192. So that means I'm going to have an x-intercept of 192, 0, and this was 0, 960. So that's what my inequality is going to look like. It's going to be a solid line because it's equal to. This is what the line would be if I only wanted them to have exactly 72,000. Any point that is on this line would give me exactly 72,000. In fact, let's go ahead and put this equation into the calculator just as an equation for now, just to see what are some values that would get us exactly 72,000. All right, so I've got my TI-84 open now. So I'm going to go to y equals, and I'm going to put in that equation, which was negative 5x plus 960. And I'm going to go ahead and look at the table. And the way that I get to the table is by doing second graph. So let's do second graph and go look at the table. And there, of course, is the y-intercept at 0, 960. And we figured out that the x-intercept is at 192. Now, I don't want to just scroll down here until I get to 192. That would take me a long time. I can jump straight to 192 though by doing second window, and I can have the table start at 192. So I'm going to start at 192. I got the second window is how I did that, and then do second graph, and there's our 192, 0. So that's the value of the x-intercept, which again is if we bought only class rings, we could buy 192 of them, and that would give us the $72,000 without buying any yearbooks. But as I scroll up here, every one of these numbers is a valid solution to this equation. Remember, we're graphing an equation for right now. So 183 and 45, the point I just landed on it randomly, means the x is 183 and the y is 45. Remember, x was class rings, y was yearbooks. This means 183 rings and 45 yearbooks. That would also be $72,000. So if we bought 183 rings and 45 yearbooks, that would get the job done. Let me scroll up a little bit more and I'll just stop somewhere at random. 127, 325. If I bought 127 rings and 325 yearbooks, that would also get us there, right? That would be enough for $72,000. If I graph this on the graphing calculator, I don't see anything on the graph, and that's because the graphing calculator by default goes from negative 10 to positive 10. But now that I've figured out the intercepts, I know how much of the graph I need to see. I need the y to go from 0 to 960, because that was the highest it went. And I need the x to go from 0 to 192, because the domain was from 0 to 192 and the range was from 0 to 960. So let's press the window button on our calculator and let's make the x go from 0 to 960. I don't want to go by ones because this is so big. Let's make it go by, let's say 30s. And then the y, oops, I got that backwards. The x needs to go to 192. Whoops. Okay. And then the y needs to go from 0 to 960. Let's have that go by 30s as well. And so now I'm going to go ahead and graph it. And there's my graph from 960 down to 192. And I'm just going to press the trace button, and anywhere along here, now the trace button gives me decimals, which is not super helpful, but anything along this line is a potential solution. Again, when I press the trace button, it gives me decimals because the calculator doesn't know it needs to be a whole number, but you get the idea. So let's go back to y equals. And it turns out the calculator will actually graph inequalities for you. If you go over to where this, see I've got the line part highlighted. It's blinking on that line part. I'm going to press enter. You can change the color, of course, but I'm going to go down to line. And I'm going to arrow over one time, and you see how it changes from a line to this triangle, and it's sort of like an up-high triangle. This means shade above the line. If I arrow over again, that low triangle means shade below the line. So I'm going to go back. I want to shade above the line because this was a greater than problem. I'm going to go to OK. So now it's going to graph this, and it's going to shade above the line. So I'm going to go ahead and press graph. And there's what it looks like on the calculator when I do greater than. So now, not only any point on the line would work, but any point in the shaded section would also work. So I'm going to drop this into our notes, a screenshot of this, so we can sort of examine this a little closer. All right, so here's a screenshot of what we got on the calculator, and we know a few of these points. We know that this point right here was our 0,960. And we know that this point right here was our 192, 0. And we know any point along that line also works as a solution here. But there's a point right here. That point right there is also a solution. I don't know what that point is. Could be anything. Honestly, I know it's lower than 192 and lower than 960, right? So maybe this point is like, I don't know, let's say it's 180 and 700 maybe, right? I'm guessing approximately. That could also be a solution. This point right here, I don't know what point that is. Let's see, that looks like maybe it's 30, 46, maybe that's like 110 and let's say 900. That's also a solution because it's in the shaded area. Now we set up our graph to stop at 960 and 192, but we could have zoomed out more on our graph. This shaded area would keep going. It would be shaded all up in here as well. All up in here, this would be shaded if we zoomed out more on our graph. And that's because the sky's the limit here for this problem. We wanted at least $72,000. The company that wants us to make $72,000 is not going to stop us if somebody comes in and says, I want to buy 4,000 class rings and 2,000 yearbooks. They're not going to stop and say, whoa, 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 our goal was 72,000. That's too many. They're going to say, yeah, of course, buy as many as you want. You can have a million. I don't care. So there's going to be a point up here somewhere that's the guy who's like, I want 4,000 class rings and 2,000 yearbooks. Will that also get us to at least $72,000? Of course it will. 192 is just the least amount of class rings we could buy with no yearbooks and get to our goal. And 960 is the least amount of yearbooks we could buy with no class rings and get our goal. But we can go way higher than that. I could say I want to buy 400,000 class rings and 0 yearbooks, and that will be a solution to this inequality. So when I said at the beginning there were a bunch of solutions, I wasn't kidding. There are an infinite number of solutions here because since it's greater than 72,000, any combination of yearbooks and class rings that get us above 72,000, we are happy with, and that is an infinite number of solutions.